Hey, this is Dan here from Math for Love, and as the school year is getting started, it just occurs to me that a lot of you are about to take algebra or deal with algebra or pre-algebra, and you're about to learn a bunch of tricks. But it's rare that someone actually stops and says, why is this actually worth learning? What's so great about this? And so I want to show you what's awesome about algebra, and I don't mean awesome like cool, I mean awesome like ridiculously powerful. And I'm actually going to do it with a little trick. So let's start there. This is just a little magic trick, and it goes like this. Think of a number between 1 and 10. So just go ahead and think of it. You can write it down if you want to. You might pick 5 or 7. Add 2 to the number. Multiply times 2. So you've got that. Then subtract 2. And when you've got that, divide by 2. And then subtract your original number. Now at this point, and here's the trick, I'm going to tell you what your answer is. Your answer is 1. Now, if you didn't get 1, go check your steps. But if you did, you might say, well, that's not that special. Well, let's actually do an example first. Let's say I take 4 as my number. So I'd add 2 to 4, I get 6. Multiply times 2, I get 12. Subtract 2, 10. Divide by 2 is 5. And 5 minus my original number, well, my original number was 4. So 5 minus 4 is 1. Pretty cool. And that's neat, but it's not too impressive. First of all, I've limited it a lot because I said pick a number between 1 and 10. So I could have just checked that this works for all the numbers from 1 to 10. It's not that big a deal. And in general, when I see something like this, the first thing I think of is, well, how can we break this? What's the counterexample? What's the number I can put in that won't come out with an answer of 1? That'll just break this apart. I always love to break my math. So let's try something else. I could take away that restriction that we're only going to go from 1 to 10. So what if we start with a bigger number, like 99? That seems like it really might end up different. 99 plus 2 is 101. Multiply times 2 is 202. And I subtract 2, I'm at 200. And half of 200 is 100. Oh, wait a minute. Then 100 minus 99 is 1. Huh. So it still works for 99. Well, that's a little more unexpected. But I bet we can still break it if we go bigger. So let's go really big. Let's go 5,677,244 and see what happens. So, okay, use a calculator if we need it. This is getting up there. We'll add 2. Well, that's not hard. Just 5,677,246. Multiply times 2. I did use a calculator for this, and I got 11,354,492. Now I subtract 2. Well, that just changes the units place from a 2 to a 0. And I divide by 2, and that's 5,677,245. I subtract my original number. Oh my gosh, look at my original number. It's only 1 away. The difference is 1. Well, now that's a little scary, actually. I mean, if it's working for numbers in the millions, it seems pretty unlikely that I'm testing all of these. Yeah, I feel like I need a different approach to try to break this. Let's try negative numbers. I bet that'll do something weird. -7, that's my number. And it seems like there's a pretty good chance to break this apart. I'll add 2 to -7. Now, adding +2 to a -7 will actually take me to -5. It's like $7 of debt, and then I make $2, so now I only have $5 of debt. I multiply times 2, well, now it goes to -10. Subtract 2, and that's like my debt growing bigger. It takes me to -12. And then I divide by 2. That takes me to -6. And now I have, subtracting my original number, so it's -6 minus -7. Well, I'm taking away a number that's 1 less. That means my answer is 1 again. Well, that's actually getting crazier. I mean, okay, so maybe this negative example didn't work. What else can we try to break this? I guess where we can go is to fractions, like to small numbers. So 1/8, that's pretty small. Let's try it. So let's see if we can keep track of all this. So 1/8 plus 2 is 17/8. I've expressed the 2 as 16/8 and added that on. And again, you can feel free to pause and try these out on your own or do your own for any of these and see if you can break this too. I'm trying some that I like. And multiply times 2, so that would be 34/8, or I could reduce it to just be 17/4. I subtract 2, so I'm going to take away 8/4, which is going to leave me with 9/4. And then I divide by 2, that'll be 9/8, and now I have 9/8 minus my original number, which was 1/8. 9/8 minus 1/8 is 8/8, which is 1. It still works! And now this is really getting troubling. We've tried some things. We've tried to find what's called a counterexample. We've looked for an example that'll prove that this trick doesn't work. We've tried some big numbers, negative numbers, fractions, but we haven't really proved anything. I would say we've proved almost nothing. We've proved it worked for a couple things, but if you're going to try one of these numbers, if you're going to try 0 or a negative fraction like -47/99, or some strange decimal like 0.02113, or what about like a negative number that has a really large absolute value and also is a decimal, like -9,999,924,598.003. You know, how could we possibly check all these numbers? I mean, if we're just going through and checking one at a time, numbers go on forever, just whole numbers go on forever. And that's not even counting fractions and decimals, which are incredibly deep. I mean, it's just baffling. And that's not even counting things like pi. I mean, pi, as you might know, the decimal expansion goes on forever without repeating. We can't even write the number down. It doesn't even seem clear how to check a number like pi. So we've done all this work, and this trick seems to work, but we don't actually know that it does. To prove that it always does would take an infinite amount of work. We'd have to check all of these infinitely many numbers. But to prove that it doesn't always work, you just have to find one case where it doesn't. If you try like, 12.5, try that and it just happens not to work, that means the trick doesn't work all the time. There's something going on. And this is what we want to know. Have we stumbled on something about the nature of numbers that's always true with this trick? Or, I don't know, does it just happen to work sometimes? You know, and if it only works sometimes, when does it work and when doesn't it work? It baffles me that it can be so easy and keep working, and yet I have no way to get a handle on whether it's really always true or just, really a trick that just happens to work a couple of times. Well, algebra is the technique. It's the method by which we can do an infinite amount of work. And it reduces an infinite task into really an easy computation. One of my favorite quotes about algebra is this one from J. Willard Gibbs: "The human mind has never invented a labor-saving device equal to algebra." And this is why you have a little magic trick like this, and checking that it works, if you just tried it arithmetically, going one number at a time, it would take you an infinite amount of time. With algebra, you can do it in less than a minute. Now, I'm not going to show you how to use algebra yet. I feel like this is the right length of this video. So in part 2, we'll actually come back and solve the puzzle and see how algebra can tell us whether it really is always true that you end at 1 when you apply this magic trick to a number. But here's some questions for you before that comes out. Can you find a counterexample? And by that I mean, can you plug in a number into this magic trick and have it not end up at 1 when you're done? And what would it take to convince you that every number does indeed end up at 1? Like, what would really constitute a proof to you other than trying out every single number? Or maybe that's the only way to do it. Maybe you really do have to do an infinite amount of work and try out every single possible number. But if not, what would it take to convince you? And just to make it a little more interesting, if anyone can find an honest answer to this, so if you search and you find some number in the trillions that has a complicated decimal, or maybe you just try in like some number I haven't checked yet, 0.11, and you try it out and it works, contact me or add it to the comments, and I will give you a cash prize of $100. By an honest answer, I mean a finite number, a real number, no trick answers, I guess. You can't say, I mean, you can try, but I have to sort of agree that it fits. Infinity, I'm not going to accept. So that's it. I'll be back with how to approach this problem using algebra next time, and what is the awesome power of algebra in terms of breaking apart things like this. And I'll leave those up for you. All right. Till next time.